Okay, so we've been talking about the exponential and logarithmic functions for the last couple of classes, and what we're going to do today is we're going to talk about the applications, just a couple of examples. And we're going to start with the compound interest. Now we have two types of compound interest, the discrete and the continuous. This is a formula for the discrete compound interest, which is the one that it's a little bit more widely used. And it's got a couple of parts that it's important for us to identify. The first one is the amount, which is going to be our final value, okay? The amount at the end of our credit, or the amount of something that we're going to get at the end. The principal, which is the value that we start with, our initial value. And then we always have a 1, because remember this 1 stands for the 100% that we start with. Then we have the interest rate, which is at the rate that our money or our substance or our things are going to grow at. We're going to use it in its decimal form. We usually get it in percentage, and then we transform it to its decimal form. Then we're going to get n, as n is the number of times interest is compounded per year. We're going to see later on in the example what we mean by this, but this is a very important number, and we find it twice in our formula over here and in the exponent. And finally, the time in years. Usually when we talk about compound interest, we need to refer to in years. So let's move on to our first example. Okay, so this is our first example of compound interest, and whenever we're dealing with compound interest, the hardest part is going to be the first part, which is identify what we have. So it says if 1,000 pesos or dollars, whatever we want, are deposited into a savings account subject to compound interest at an annual rate of 3% compounded annually, calculate how much money will be in the account after 5 years. So the first thing that we're going to do is identify what we have. So we have $1,000, which is going to be your principal, or the money that we start with. So we have 1,000. Then it says that we have an annual rate of 3%, so the rate is going to be 3%. And we said that we were going to express that in decimals, so we're going to write 0.03. Then the n, if we say that we're compounding annually, that means that we're going to compound just one time per year. So n is going to be just 1. We're going to see how that changes when we get different things. But when we have something that says compounded annually, means that we're going to do it once a year. And the time is the time that it's being indicated over here. Calculate how much money will be in the account after 5 years. So t is equal to 5. After we have identified everything, comes the easy part, which is substituting our formula, for which we're going to get the final amount. So a is equal to, first the principal, times 1 plus the rate, 0.03, divided by 1. We said that n is equal to 1 because we're compounding annually. And this is going to be to the power of 1, and again, times 5. So at the very end, we're left with 1,000 times 1.03 to the power of 5. This is going to be equal to 1,159.27 cents. Okay, and then the second question says find the interest earned. So if we started with 1,000 and we got 1,159.27, the interest earned, I'm going to change the color here, is going to be equal to the final amount minus the initial principal. So basically A minus P. So what we have is that the interest earned is equal to 1,159.27 minus 1,000. At the very end, we won $159.27. Okay, so for this second example, we have something similar, but we are compounding monthly rather than annually, so it works a little bit different. We're going to start with the same information. So we have a principal of 1,000 and a rate of 48%. And if you read the statement, it says that we have $1,000 owed to a credit card, with compound interest at an annual rate of 48%. This is actually very accurate to real life. So if you owe $1,000 or 1,000 pesos at a rate of 48%, we're gonna see how much you end up paying, but it's a lot. What we're gonna have over here is n. We're gonna have an n of 12 because this interest is compounded monthly. That means that it's gonna be compounded 12 times per year. And it says calculate how much money will be owed in 5 years. So the time is equal to 5 again. What we're gonna do here is we're gonna use the same formula. So A is equal to 1,000 times 1 plus 0.48 over 12. 0.48, which is our rate expressed in a decimal form, and 12, which is the amount of times our interest is going to be compounded in a year. And then over here, the exponent is going to be 12, again, n times the time, which is 5. So 12 times 5, we're going to get 60. We're left with 1,000 times 1.04 to the power of 60, and this is equal to 10,519.63. So that's why we call it exponential growth, because you started owing $1,000 and at the end of 5 years you owe 10,000. This is very, very accurate to what happens with credit card. And the interest due, in this case, is not the interest, it's not the interest earned, but the interest due is going to be the same thing. A minus P, and in this case is minus 9,519.63. This is why you ended up paying at the very end of the credit life. Okay, so we worked with the compound interest formula, but we can also derive from that same formula the present value formula, which is the one that we have on the bottom. So basically, if we said that A is the amount of money that we're going to get at the end of a certain interest, and P is the initial value, we can also get the initial value if we have the future value. And basically, we just isolated P from this part. So this whole thing is going to pass to the other side, to the denominator. And we're going to use this formula as follows. So we have this example, and it says, how much do I need to place in my savings account so that I can have 500,000 pesos in 10 years with an interest rate of 3% compounded monthly? Again, very accurately to the interest rates that we have in saving accounts nowadays. So first, we need to identify what we have, and it says that we want to have 500,000 pesos in 10 years. So what we want at the end, the amount at the end that we want is 500,000. The time in which we're going to try to get it is 10 years. And the interest rate is 3%, therefore 0.03. And finally, we said that we're compounding monthly. So again, n is going to be 12. Okay. So what we're going to do is we're going to use the formula for the present value, or for the principal that we want to get. And the principal is going to be equal to 500,000 divided by 1 plus the rate that we have here, which is 0.03, over n, which in this case is 12. Again, we're compounding monthly, so 12 months a year, 12. And this is going to be elevated to 12, again, n, times the time. In this case, the time is 10 years, so we're going to multiply times 10. We're going to simplify this expression a bit, and we're going to be left with 1.0025 to the power of 120. If we compute that into our calculator, we're going to see that we need to put 370,547 pesos with 80 cents into our account. This is the amount of money that we would need to put in right now into our saving account so that in 10 years we can get $500,000. Okay, so the example that we have here is a little bit different. It's still present value, but they're asking us different things. It says, how much time will it take for me to get 500,000 pesos if I place 50,000 pesos in my savings account with an interest rate of 2.5% compounded quarterly? Okay, so they're giving us different things. First, what do we have? We have the principal, is the amount of money that we have now, P for principal, or for present, if you want to remember it. Then the amount that we want at the end is A, 500,000, the rate 2.5% or 0.025. And in this case, since we're compounding quarterly, that means that we're going to do it 4 times per year. The n is going to be equal to 4. Now we have two possible options, two possible formulas. We're going to use the first one because at the end what we want to get is the time, and we can get it a little bit more easily with the first formula rather than with the second one. So we're going to start with the amount, and we have 500,000 equal to the principal, 50,000, times 1 plus the rate, which is 0.025, over n, which in this case is 4. Again, we're compounding quarterly. And we're going to elevate this to 4 times t. In this case, what we're looking for is t, so that's the amount that we don't have. I'm going to simplify this expression a bit. So this 50,000 pesos, I'm going to pass them to the other side, and I'm going to divide them. So we're going to get 500,000 over 50,000. This is going to be equal to 1.00625 elevated to 4 times t. Over here we just get 10 once we simplify it, and this is going to be equal to 1.00625 to the power of 4t. And since we have an exponent over here, an exponential, what we're going to do is we're going to use the logarithms to be able to solve for t. So I'm going to use a logarithm base 1.00625. So logarithm 1.00625 of 10, and then the logarithm 1.00625 of 1.00625 of 14. So what we're going to get over here is t being equal to the logarithm 1.00625. So that we have a logarithm base 1.00625 of 10 divided by 4, which is roughly, if we compute it in our calculator, 92.4 years. So we can eventually get there, but it will take a very, very long time with this interest rate.